Alright, in tonight's video we're going to take a look at ionic compound nomenclature. So how to name and write chemical formulas for ionic compounds. There are several different kinds of ionic compounds. Type 1 ionic compounds that are binary mean they have just two elements. That's what binary means. And type 1 means that the cations have only one possible charge. Type 2, the cations will have two different possible charges, and we use Roman numerals when we name them. Ionic, of course, means there's a metal bonded to a nonmetal, often, usually, or more generally that there is a cation bonded to an anion. Ionic compounds often also have complex or polyatomic ions. There's, in our data booklets at Grant Park High School, we have a list of these ions on page 6. I'll be referring to those later. And of course, there are hydrated ionic compounds that have water molecules trapped inside their crystal structures. So we'll jump in. The best way to make use of this video is not simply to watch, but to pause the video and try some of the questions yourself, and then listen to the explanations. So for sodium phosphate, we find sodium on a periodic table. Sodium is in column number 1. It's an alkali metal, and so like all alkali metals, its charge is 1 positive. So I'll just write the cation's formula is Na positive. Phosphate, because I see that ending ATE, tells me that's a complex ion. So I go to my list of complex ions. Phosphate is the guy at the bottom of our list that has a charge of 3 negative. It has phosphorus in the formula, but it's PO4 3 negative. I'm not going to flip back and forth like that throughout the video, so if you have your own data booklet at home with the charges of the ions on page 6 and the list of complex ions, that would be great. So now that I've got the two ions written, the cation and the anion, the positive and the negative ion, I just need to look at their charges, a +1 and a 3-. I want those to cancel out. So the lowest common multiple of 1 and 3 would be 3. So I need 3 of the sodiums to give me 3 positives, and I'll need 1 of the phosphates to give me 3 negatives. So the formula to show 3 sodiums, we write Na and then a subscript 3, and only 1 of the phosphates, so just PO4. Calcium iodide. Calcium is in the second column of the periodic table, so it's an alkaline earth metal. Its charge is 2 positive. Iodide, this time the ending is IDE, and that means almost always just a simple ion. So an ion with just one atom. I look on the periodic table, iodide is a halogen, and like all other halogens, its charge is -1, or 1-. Again, the charges here are 2 positive, and now we have a 1 negative. So to make those cancel out, we'll take 1 of the calciums and 2 of the iodides. So the formula would be CaI2. The next one is a little bit confusing to somebody who doesn't understand the chemistry. They might see 3 different things there, possibly even 4. When I look at this, I see 2 things. I see iron 3, and then I see hydrogen sulfide. Those are the 2 things. Because there's a Roman numeral, this must be a type 2 cation. Iron has more than 1 possible charge, and that Roman numeral is telling me what its charge is. So the cation here is Fe3+, because the Roman numeral was a 3. Hydrogen sulfide. Sulfide ends in IDE, so that leads me to think it's a simple ion, just 1 atom, but there's a hydrogen attached. Sulfide is normally S2-. That's sulfide. It's underneath oxygen on the periodic table. If you attach a hydrogen, which has a charge of +1, to that, what you'll get is a complex ion, HS, and its charge, a +1 and a 2 negative, is -1. So you can look it up on your polyatomic or complex ion list, or you can just reason it out like I did there. Now looking at the charges, a +3 or a 3 positive, and a 1 minus. We're going to need 3 of those HS's to cancel the iron's charge. So Fe. Now how do I show 3 of the HS's? I don't want to just put a subscript HS3 because then that 3 refers to just the sulfur. If you have a complex ion, put it in brackets first, then put the subscript outside the brackets. So notice we only use the brackets for complex ions. We wouldn't put it around a simple ion with just one atom. And you only put it around complex ions when there's more than one of them. For example, in sodium phosphate up above, phosphate doesn't have brackets because there's only one phosphate in the formula. Number 4, copper 2 nitrate, hexahydrate. That has 3 pieces. Copper 2, nitrate. Those make the ionic compound. So copper 2 is again a type 2 cation. Copper has more than one charge. So that one is copper 2 plus. Nitrate, because there's that ATE, that's the clue that it's a complex ion. Look it up on your data booklet. It's NO3 minus. So let's just write the formula for these two bonded together. A 2 positive and a 1 minus. We're going to need 2 of those nitrates to cancel the charge of the 1 copper. So to get 2 nitrates, I put it in brackets like this, and then put a 2 outside. But what about that hexahydrate in the name? What does that mean? Well, there is the hydrated ionic compound. Those are compounds that have water molecules trapped within their crystal structures. And when it says hexa, that prefix hexa means 6. So for every formula unit of copper 2 nitrate, we put a dot and we say there are 6 water molecules associated with it. If you put this salt in a crucible and heated it in the lab, you could drive the water away and you'd be left with the anhydrous version of copper 2 nitrate. It would be the same formula but without the 6 water molecules attached. Aluminum dichromate. So aluminum on our data booklet, page 6, is 3 positive, and dichromate is a complex ion. You can see it on page 6, Cr2O7, 2 negative. Looking at the charges, this is one of the more complicated ones, but it's still not hard. You have 3 positives and 2 negatives. Well, the lowest common multiple of 3 and 2 is 6. So if we can get 6 positives and 6 negatives, we are going to be good. So to get 6 positives, we're going to need 2 of the aluminums, so Al2. And then to get 6 negatives, we'll need 3 of the dichromates, because they're each 2 negative. Since I've got more than one, I'll put them in brackets, and I'll say 3 outside the bracket. Potassium bromide. Potassium is an alkali metal. +1 is its charge, or 1 positive. Bromide is a halogen. Their charges are 1 negative. A +1 and a -1 cancel out. So the formula will just be KBr. Now I should point out that in all of these examples, we're starting with either a metal cation, like sodium, calcium, iron, copper. Sometimes we'll get a complex cation, like ammonium. And they're bonded to non-metal anions, phosphate, iodide, hydrogen sulfide. That's why these are ionic compounds, right? They've got metal cations almost always, and they have non-metal anions, and it's opposite charges attracting that are holding them together in the compound. Zinc sulfate. Zinc is a transition metal, so you either have to know its charge or you look it in your data booklet. It is 2 positive. Sulfate, the ATE, tells me that it's a complex ion. Probably has sulfur, sulfate. So I look it up in my book, SO4, and its charge is 2 negative. Now the charges, 2 plus and 2 negative, they're equal. So I just need 1 zinc bonded to 1 sulfate, and we're done. Gold 3 chloride tetrahydrate. So this guy again has 3 pieces. The first 2 will make the compound that we're looking for, and then we'll add on the tetrahydrate at the end. So gold is a transition metal. Gold 3 is telling me that its charge is 3 plus. Gold has more than one charge, so this is the stock system when you use Roman numerals to tell the charge. Chloride is a halogen. Its charge is -1 or 1 minus. So because we have a 3 and a 1 minus, we're going to need 1 gold and 3 chlorides to make the charges cancel out. So AuCl3. There's gold 3 chloride. Now let's deal with the tetrahydrate. That is a hydrated compound, so we show a dot. Tetra means 4, and there's 4 waters attached with every gold chloride, so we write 4 H2Os like that. Barium chlorite. Barium is a alkaline earth metal. Their charges are always 2 positive. Chlorite is a complex ion. Ite or 8 are complex ions, and this guy is ClO2. You can look it up in your data booklet. Its charge is 1 minus. 2 plus and 1 minus, so I'm going to need 1 of the bariums and 2 of those chlorites. So because it's a complex ion, we'll put it in brackets and show the 2 outside. Again, I hope you're not just watching and listening. I hope you're pausing at each question, trying it yourself, and then listening to the explanation to see if you've got it right. Silver arsenide. Silver is a transition metal. Its charge, looking in my data booklet, is 1 positive or just positive. Arsenide, the IDE, is telling me that's a simple ion, not a complex ion. So its symbol is As, arsenic. And arsenic is in the same column on the periodic table as nitrogen. So like nitrogen and like phosphorus, its charge is 3 negative. Now we have a 1 positive and a 3 negative. To make those equal, I'll take 3 of the silvers and 1 of those arsenides. So Ag3 shows me 3 silvers and 1 of the arsenides. Cobalt 3 sulfide, there's 2 pieces of an ionic compound, and then we'll add monohydrate at the end. Cobalt is CO. Cobalt with a 3 Roman numeral means its charge is 3 positive. It has more than one charge, so that's why the Roman numeral is there to tell me. Sulfide with an IDE is going to be just a simple ion with sulfur. It's on my periodic table underneath oxygen, so like oxygen, its charge is 2 negative. A 3 positive and a 2 negative. I'm going to take 2 of the cobalts, that will give me 6 positives, and I'll take 3 of the sulfides, that will give me 6 negatives. So 2 of the cobalts and 3 of the sulfides, that would be cobalt 3 sulfide. Now the monohydrate, mono means 1, so we put a dot, and we can just write the number 1, or if it is a 1, you can just leave that number out. It'll be understood. So we'll just say dot H2O. If you put a 1 in front of the H2O, that's fine. Lead 4 permanganate. So lead is Pb. It's a type 2 cation. It has more than one charge. So in this case, it's lead 4, so we'll put a 4 positive. Permanganate is a complex ion. I look on my data booklet, page 6. Permanganate is MnO4 minus. I hope you get a sense here as I'm working through this with you. I know the formulas of the complex ions. Because I know them, I've taken time to memorize them. This is actually a very simple exercise for me. I don't have to keep looking things up on the periodic table or in my data booklet. So a little bit of memorizing actually goes a long way if you're trying to get good at this. So 4 positive and 1 minus, I'll need 1 of those leads, and I'll need 4 of the permanganates. So Pb, and then in brackets, permanganate with a 4. Strontium bromide dihydrate. Let's leave the dihydrate till the end. Strontium is an alkaline earth metal. Sr with a charge of 2 positive, like all of the alkaline earths. Bromide is a halogen, same family as chloride and iodide and fluoride, so its charge is 1 minus. A 2 positive and a 1 minus will take one of the strontiums and two of the bromides to cancel out that positive charge, so SrBr2. Now look at the dihydrate, so we put a dot. For every SrBr2, there are 2 di water molecules, so dot 2H2O. Number 14, titanium 4 nitrite. So titanium is Ti. It's a transition metal. Its charge is 4 positive because it's a type 2 cation. They've told us the charge with the Roman numeral. Again, that's called the stock system. Nitrite is a complex ion. Now I've memorized that nitrate is NO3 negative. Then nitrite, with the ite, would have one less oxygen atom. It's just NO2 negative. Or you could just look that up on page 6 of your data booklet. There's a 4 positive and a 1 negative, so I'll take one of those titaniums and I'll take 4 of these nitrites. So we get Ti. Because I need 4 of the complex ions, more than one, we'll put them in brackets and say we need 4 of those. Ammonium carbonate trihydrate. So let's leave the trihydrate till the end. Ammonium is the most common complex cation. I recognize that it's a cation, NH4, its charge is 1 positive. It's on the bottom of page 6 in the list of complex ions. Carbonate is also a complex ion, but it's an anion, 2 negative. A 1 positive and a 2 negative, I'm going to need 2 of the ammoniums to cancel out the charge of the carbonate. So because I need 2 of the ammoniums, I put them in brackets and then put a subscript 2. There's my 2 ammoniums and there's my carbonate. But it also said trihydrate. So let's add dot 3 H2O. Tri is the number 3. And finally, copper 2 hydroxide, number 16. Copper 2 is a transition metal. Its charge is 2 positive. It tells us that with the Roman numeral. Hydroxide is a complex ion, OH negative. A 2 positive and a negative. I'm going to take 2 of the hydroxides to cancel out the charge on 1 of the coppers. So 1 copper and 2 hydroxides. Be sure you put the hydroxide in brackets because it's a complex ion. So I hope that helped with just basic practice. Part A, given the name of an ionic compound, we wrote the formula. Eventually, when you get good at this, you don't need to write the formulas of the 2 ions. You can just imagine that in your head and then write the formula. But if you're new at this, or if you're prone to make mistakes, putting the 2 formulas of the cation and the anion helps avoid silly mistakes. So I highly recommend that for new students to chemical nomenclature. Alright, let's move on to the second part of this nomenclature video. This time you're going to be given the formula of an ionic compound. These are all ionic compounds. They have metal cations or a complex cation, and they're bonded to non-metal anions or complex anions. This time I've got a column in the middle that asks, is there a type 2 cation present? If there is a type 2 cation, we're going to need to use the Roman numeral in its name. We're going to figure out what its charge was and put that as a Roman numeral in the name. So I'm going to be referring to page 6 of our data booklet. Remember, the type 2 cations are the ones that have more than one possible charge. So most of them, but not all of them, are transition metals. Those are all transition metals. But there are a few over here that are also type 2 cations. These are not the only type 2 cations, but these are the ones that are in our data booklets that have been highlighted. So wherever you have a type 2 cation, we need to use the stock system with a Roman numeral to indicate the charge. So let's jump in. The first one, again, pause the video and try it yourself once you understand what you're doing. So the cation is always the first thing in the formula. So in this case, sodium is the cation. Sodium is an alkali metal. Those are not type 2 cations. They don't need Roman numerals. So given that, I'm just going to simply name the cation, in this case sodium, and then I'm going to name the anion. The anion here is SO3. I can look that up in my data booklet. Its charge must be 2 negative because it has 2 sodiums attached. But I look it up, SO3 2 negative is sulfite. So sodium sulfite is the name. The next guy starts with copper, and copper, I'm not going to do this all the time, but copper is one of the type 2 cations. It can be a 1 plus or it can be a 2 plus. Let's see what we have here. So this is a complex cation. Well, which one is it? Is it a 1 plus or a 2 plus? To figure that out, look at what it's bonded with. In this case, it's bonded with bromide. Bromide is a halogen. Its charge is 1 minus. But in the formula, there's 2 bromides bonded to that 1 copper. So if you have 2 of the negatives bonded to the 1 copper, then that copper must be copper 2 positive. There's the type 2 cation. So its name, I have to tell you the charge as a Roman numeral. So copper brackets Roman numeral 2. I'd put the Roman numeral to tell you that it's the 2 positive copper and not the 1 positive copper, the other possible ion. And then bonded to that, we have the bromide. Remember that if it's just a simple ion, just Br, not a BrO3 or something, then it's our simple ions will always end in IDE, so bromide. The next guy starts with calcium. Calcium is an alkaline earth metal. Those are always 2 positive, so that's not a type 2 cation. So we can say calcium, and then CrO4. I looked that up as a complex ion. It's clearly not a simple ion. It has more than 1 atom. So CrO4 is called chromate. So this is calcium chromate. The next guy is Li3ASO4. When you look at that, do you see 2 things? Do you see the lithiums? And bonded to that is this ASO4. Lithiums are alkali metals, so those are not type 2 cations. There's no need for a Roman numeral. So we can just say lithium. And ASO4 is clearly a complex ion. It has 5 atoms, 1 arsenic and 4 oxygens. So we look it up on the in our data booklet, page 6. It's called arsenate. So lithium arsenate. Notice that other than type 2 cations, we don't even care what the charges are when we write the names. The only time we worry about the charges is to figure out the charge on a type 2 cation. The next guy is a bit more complicated. I see those water molecules at the end, so I know it's going to have a hydrate at the end of its name. So for now, let's just ignore that and look at the beginning part. It has a lead, and then it has 4 of these ClO4 minuses that are in the brackets there. So the lead, I recognize, is a type 2 cation. Lead has more than 1 possible charge. Let's figure out what its charge is. Well, it's got that ClO3 in the brackets. That's a complex ion. And so you look that up in your data booklet. Its charge is 1 negative. But there are 4 of those. Look at the formula, the 4 outside the brackets. 4 of these are bonded to the lead, to 1 lead. So what must the charge be for that 1 lead? Well, if you've got 4 negatives attached, it must be lead 4 positive. So the name would be lead, then Roman numeral 4, which is a letter I followed by a capital V, and then the name of that ClO3 negative from my data booklet, if I don't recognize it, is chlorate. And then finally, what about the 5 water molecules? Well, the prefix for 5 is penta, like a pentagon. And then when the water molecules are there, we say hydrate. So pentahydrate. So lead 4 chlorate, pentahydrate. The next guy does not have a type 2 cation. Zinc is a transition metal, but its charge is always 2 positive. So this is very simple. Zinc, and then P by itself is just the element phosphorus. It's not a complex ion, so it's a simple ion, and its name will end in IDE, so phosphide. Aluminum is not a type 2 cation. It always has a charge of 3 positive. So this is aluminum, no need for a Roman numeral. And then in brackets, the OH, there's 3 of those, but OH from my list of complex ions is hydroxide. Nickel jumps out at me. Yes, it's a complex cation. So we have to figure out what its charge is so we can say it with a Roman numeral. In the brackets, CH3COO is actually CH3COO minus. That's on my data booklet complex ions chart. It's called acetate. Some people would call it more properly ethanoate, but the common name is acetate. So its charge is -1 or 1 minus, and there are 2 of those bonded to the nickel. So if you've got 2 negatives bonded to the nickel's charge must be 2 positive. So this is nickel in brackets Roman numeral 2 to say that its charge is 2 positive, and then acetate unless your teacher wants you to say ethanoate. The next guy has strontium at the beginning. Strontium is an alkaline earth metal, not a type 2 cation, so its name is just strontium. Cls, those are just chloride ions. They're not complex ions, so chloride. And then the 3 waters would be tri, means 3, and the waters again are hydrate. So strontium chloride trihydrate. Number 10, gallium is not a type 2 cation. It's underneath aluminum on the periodic table, and its charge is always 3 positive. So this is gallium, no need for a Roman numeral. And then in the brackets there's carbonate, CO3, and it's got 3 carbonates bonded with the 2 galliums. Carbonate is a complex ion, which I recognized, so its name is gallium carbonate. Again, I hope you're not just watching and listening, but that you're pausing at each question and trying it yourself first. Number 11, cobalt, CO, is a type 2 cation. I look at my data booklet if I don't have these memorized. Cobalt can be 2+ or 3+, so we're going to need to figure out which one of those we have here. To figure that out, we see what it's bonded with. IO4, well, that's called periodate. Again, it's over here on my list of complex ions, periodate, IO4 minus. So its charge is just a -1. So IO4 -1 or 1 minus. Now we have 3 of those. Look outside the brackets, there's a 3. So 3 of these are bonded to the cobalt. Well, if you have 3 negatives attached to that cobalt, that must be cobalt with a charge of 3 positive. So now I can say this is cobalt, Roman numeral 3, so you know it's the cobalt 3 positive. And then that other guy bonded we said was called periodate. That's the anion attached. Mg, number 12, is an alkaline earth metal. They're not type 2 ions. They have only 1 charge, which is always 2 positive. In the brackets, BRO, one more time, that is the hypobromite ion. Here it is on my list of ions, hypobromite. So the name for this guy would be magnesium. hypobromite. And then it's got 7 waters attached. So 7, the prefix for this one is a little bit hard to remember, but it's hepta. H-E-P-T-A. Hepta means 7, and then hydrate. So magnesium hypobromite heptahydrate. That's a real mouthful of a name. Number 13, tin, SN, is a type 2 cation. So we need to stop and think about what its charge is. It has 4 of the iodides. Iodides are just halogens, so their charges are each -1. Oops, I'm putting that in the wrong spot. It's got 4 of these iodides attached. That means the tin must have been 4 positive. Since each of those iodides is 1 negative, 4 iodides means the tin had to be 4 positive. So this would have been tin, Roman numeral 4, there's its charge, and then iodide. So notice when you're naming these complex ions, these ionic compounds, you're just naming the cation. If it's a type 2 cation, you throw in a Roman numeral, and then you name the anion. If there's water attached, then you add on trihydrate, heptahydrate, something like that. Number 14, barium sulfate. Barium is not a type 2 cation. It's an alkaline earth metal. Look on your periodic table. So barium does not need a Roman numeral. And SO4, it's one of the most common complex ions. That is sulfate. The next guy's formula is a little bit weird with subscripts 3 and 4, but we don't really care. It has titanium, Ti. Well, you know what? I do care now because we're going to need to figure out its charge. Titanium is a type 2 cation. So let's see what's bonded to it. There's these nitrides, and there's 4 of those. Well, I look on my periodic table, and nitride is 3 negative. So ready to do some mental math. You have 4 of these nitrides. So 4 times 3 negative, that gives me a total of 12 negatives. So there must be 12 positives to cancel that out. Those 12 positives are on 3 titanium atoms. So if you have 12 positives and they're on 3 titanium atoms, 12 divided by 3, each of those titaniums must have been Ti4 positive. So this was titanium Roman numeral 4, because that's the charge on the ion, nitride, the simple ion, N3-. And then we see that dot H2O. There's no number in front of the water, so that means it's a 1. And the prefix for 1 is mono, and then the water, hydrate. So titanium 4 nitride, monohydrate. And lastly, ammonium, NH4, I recognize as a complex cation. Comes beginning of the formula, so it must be a cation. So that's just ammonium. It's not a type 2 cation because it's a complex ion. Ammonium, NH4 positive. And then what is HPO4? Well, I know that PO4 3-, whoops, wrote a B when I meant a P. I know that PO4 3- is called phosphate. So if you add a hydrogen and you get HPO4, hydrogen's charge is 1 positive. So if you add a 1 positive to that 3 negative, that's going to give you a 2 negative. So this thing is called hydrogen phosphate. PO4 3- was phosphate. If you put a 1 hydrogen with it, it's called hydrogen phosphate. If it had 2 H's, then the charge would now be only 1 negative, and now the name would be dihydrogen phosphate. Or you can just look that up in your book here. The HPO4 2-, That is hydrogen phosphate. Where am I seeing that? Oh, it's a 2 minus, so it'll be over here on the right-hand side. There it is, HPO4 2 minus, hydrogen phosphate. So the proper name would be ammonium hydrogen phosphate. All right, so that was a good review of ionic nomenclature. I hope that helps. There's another video if you want more practice with not only ionic compounds but also covalent compounds and acids mixed in with it. So another video where we review basically all of the nomenclature in this unit for chemistry.